HDB3, or high-density bipolar 3 zeros, is a line coding scheme that is based on bipolar AMI, so I would recommend learning about it first before watching this. So basically, HDB3 works just like regular bipolar AMI, but it also utilizes substitution patterns to replace sequences of 4 zeros to ensure clock synchronization. So with HDB3, whenever there is a sequence of 4 zeros, it is replaced with a special substitution pattern. So here, we have the table for the rules of HDB3. So, as we can see, the substitution pattern depends on the polarity of the preceding pulse and the number of ones that have occurred since the last substitution pattern. So, for example, with this sequence of bits, the first 3 bits is encoded just like in regular bipolar AMI, but then we get 4 zeros, so now we have to use the substitution patterns. And because the last pulse was negative, and the amount of ones since the last substitution pattern is 2, and since that is an even number, this pattern is used. Let's say that we then get a 1 and 4 more zeros. So the 1 is encoded just like in bipolar AMI. And as the last pulse's polarity from the substitution pattern is positive, this one will therefore have negative polarity. So the conventions of bipolar AMI is continued from here, and not from the 1 bit that precedes the substitution pattern. So next we have 4 zeros. So now, because we had a single 1 bit since the last substitution, and that is an odd number and its polarity is negative, therefore this pattern is used. So, as we can see, these substitution patterns that replace the 4 zeros violate the rules of regular bipolar AMI, due to the 1 bit being the same polarity as the preceding one. And therefore, these specific violation patterns can be interpreted as 4 zeros by the receivers, instead of as an error in communication.